Okay, in implementation of, oh, I never added it, right? Oh, I never added it. Let me actually add size to our code to demonstrate. So if I said size t, size const, and say return return 0 under development, right? So the function is not implemented. And of course, I need to add the qualifier of the node scope to the function signature and save everything. And if I try to go to my main function and perhaps over here I could print of course, it's not going to do anything interesting because it returns 0, but nevertheless, let's make a call. So say node A size just displays the size, right? And we can print a new line. Okay, something like that, something really primitive. So let's now compile this. Right. So let's compile this. And I don't expect it to be, I'm still debug. Why is it? Oh, distance. Where am I referencing distance? It is not happy about the distance. The distance here, am I using it anywhere? Yeah, I'm trying to use, so I'll just comment this out. Don't worry about it. All right. So that succeeds, and if I run it, it says list size is 0, which is a lie. It's under development. But I do have a function, and I make this function call right here. Node A, tell me what the size of the list is. And node A, in my case, easily recognizable as the root of my list, right? Because it seems like everything that I do, pretty much I use my root to do a lot of work with this list. By design, because it's a single direction, you know, this node points to another one, points to another one. So really, to do something useful, start at the head, at the root of this list. So let's try something like this. Data equals 0. Okay, so size should not, you know, if you look at the interface, it says size is member function of the node class. It says calculate number of nodes in the list, right? Basically tell us what is the size of this list. By all means, this function should not be designed and coded to change any data. So perhaps this was done by mistake. But telling the compiler that we intentionally want this function to be read-only with respect to the data inside of our class, this will not compile. Let's try to build this and see what error message we get. And it says data cannot be modified because it is being accessed through a const object. So the idea is this: when someone calls size, inside here, this object node A has to be treated as a constant object, as an object sitting in constant memory. Therefore, any attempt to modify its memory should fail, and it fails during compile time. So this is why we would like to use const qualifiers on member functions whenever possible, right? That's why print function should not modify anything. It should be marked as constant. So is the distance. The distance by all means should not do something inside the list which would modify any single bit of it, right? It should only do read-only access to the data, and that's why declared const. Interestingly, if I forgot to, and I don't really have implementation of the distance here, but let me try something like this. I don't know. If then I say, oh no, this was mistake. This was big mistake. Let's fix that. It was totally unintentional. We understand that this function is const. But look at function remove next. Does it modify our list? Of course, it does. Great potential to modify our list. So then, if I just go ahead and again make another mistake, say, let me call this function. Now, look what happens. If we try to build it, the error message is another a bit strange. It says, remove next. If you double click, it points to this intent to call. It says, cannot convert this pointer from const node to node reference. What it really means is a cryptic indication that you have a const function, but you're trying to call a non-const function because look, remove next doesn't have a const qualifier next to its declaration. Therefore, we will never allow this. If you would like to do this, you better then either do this, make this function const, which will not be possible because we know remove next does make changes, and now this will not compile. Or otherwise, if you intend to do something crazy like this, then this should not be part of the size declaration. So this is a great way to design interface of our class and basically keep those very simple checks in place so that we can say under no circumstances size should be doing anything to modify our data inside of our object, including calls to non-const functions. Even here, the compiler stops us from doing this. So this cannot be done, and it's by design, because this is a non-const function. This function, however, is const. You might say, well, look, I can solve all of these problems if I just get rid of all of these const qualifiers. Just forget, just remove them all. There should be no problem from the compiler standpoint. Well, yes, sorry, I will bring it back. So, yes, you will be able to compile, but then there is no checks against unintentional things. So this is your friend. In fact, I probably don't know, typically any pointer should be viewed as your enemy. And any const, any place where you can insert the const is your huge friend. Because it does two things. Prevents bad things from happening, number one. And number two, this, I already said that before, this is the primary message to the compiler. If you can, if we build release build that we want to ship to our customers, look for all these consts. Compiler can rely on these consts to optimize the code. Anytime you do this, you simply say, there's some additional rules that apply to this function, and therefore compiler can take additional steps to optimize the code and make it faster. Basically, when you use const, you're making your code faster. Your program will run faster anytime you managed to put const someplace. As simple as that. This is your incredible friend. There is no better friend as a const in C or C++, I think. And in other languages, such as, say, Java, final keyword serves as a const keyword. Same thing. Same thing. Anything that that can be made const should be made const. This is the responsibility of the programmer. This is both good design and also an incredible clue to the compiler to how it could optimize your code. So just keep that in mind. Let's save the segment.